All right, any questions, anyone? Questions? Okay, then I have questions. So I had a quick look at the assignment solutions for the room, and I find it difficult to believe that no one would have questions about this assignment, because just about everyone got it wrong, and not just a little bit wrong. I was going through those things, and so it was a hard assignment, and what I was kind of hoping for is that people would kind of get to like level 4 or 5, and I'm sure some of you did, but I looked at a whole bunch of them, and I said, this can't possibly be right. So here is one example. Oh, we can't see this? Hang on. There we go. Let's see. So here's, is the window valid? So I'm looking at it, and it says, is window x greater or equal than 0? And is window y greater or equal 0? And is window x at most width? And is window y at most height?
Can we turn off like one light?
Yes. And I can maybe also make it bigger. Let me see if I can make it bigger. I apologize if in the process I reveal the whose name this is. F11. It'll all happen. Okay. Is this better? So window x greater equals 0 and window y greater equals 0, window x less equal width, window y less equal height. And?
No. Yeah. Oh, it's just backwards.
So here I have my ruler. Smart, yeah?
Looks like it.
My day again. Nothing is happening for me today. Come on. Okay, here. All right. So here's my room.
Yeah, just because it works with those numbers. Yeah. Well, we usually just wait around. That's true.
Okay. Bunch of crap. So here's my room. And so let's pick some window x and y coordinate like here. I'm going to put my window right in the middle of the room here. I put it right there where the stop is. Here should be my window. Is that a good window?
No.
But it's greater or equal than 0 and less equal width than height.
Yeah, shit.
Right, so it fulfills the condition here.
Window has to be on the wall.
I know it has to be on the wall. You know it has to be on the wall, but why didn't I hear an outcry when I put this thing on the board?
Could be on top.
Let's see if it's an outlier. Maybe everyone else did this better. So, is window valid? 0 less equal window x less equal width, 0 less equal window y less equal height. Is window valid? Window x less equal width, window y less equal height. Is window valid? While the room has a right wall, if Carol this wouldn't even compile. Because this stuff only compiles when you're inside NetBeans and you have all the Carol stuff loaded. Return window y greater than window x greater than minus 0.5, less than width, greater minus 0.5, less than height. Well, it's the same problem. It checks, is it within 4 bounds like this? It's not going to check, is it along the wall? Same thing. That's 4 ands. Returns true. All windows are valid. If it's bit less than equal width and less equal height and greater 0 and greater 0, return true, else return false. So this actually has the same issue that I talked about before, that it's not a good thing to compute an expression that is true or false and say if it's true, return true, and if it's false, return false. You could have saved yourself that particular step. But the basis is still, it's the same test. It tests, is it within this rectangular area, and it doesn't test, is it along the boundary. Returns true. Have I found a correct one so far? Okay, here we have something with a bunch of ors. That's much more promising, right? Because it has to be on one boundary or the other, or the third, or the fourth. So this one could be correct. This one says, if it's less than the width or less than the height, return true. Why must this be false?
Starts at -0.5, right? That does the same thing.
So if window x is minus 20,000, it's true, right? So here we have one that is pretty long and complicated. This might be right or not. I haven't thought it through. Here's one that's kind of long and complicated. Could be right or not. This one I wouldn't put my money on. Here, so it checks. See, this again can't possibly be right just by looking at it, because it checks, are we somewhere in the neighborhood of the left or the top wall? There's nothing that checks with, or does it? Or no, it checks whether we're on the right or the bottom. It doesn't check whether we're on the left or on the top, right? There's 4 walls, and there's only 2 checks. You can't check against 4 walls with only 2 checks. So here we get again that, okay, what's wrong with this one? even on a more basic level.
Just set for one type of room.
It's just set for one type of room, right? When you see the 8 and the 6, then your heart must sink because, where's 8 and 6 come from? That was just the numbers in this particular example. In general, the 8 and 6 couldn't possibly have any relevance. Here, return true, yeah. Return true. Same problem as before. I'm not sure whether we're now cycling through this. Yeah, I think now we've seen them all. So I think I've seen 2 or 3 solutions that had a chance of being the right solution. So I'm going to reassign this for Wednesday. Okay, now next time, before you hand in this, what you must know in your heart could not possibly be the complete solution. Could you please put a question out on Desire to Learn and say, I think this is not a complete solution. Can someone help me out? You're learning nothing from giving me a false solution. And then you look at my solution, which is 4 times more complicated. And then what have you learned? That there is someone out there in the world who can solve this problem. That is not a useful piece of information. It is you, all of you, who are expected to do this right. All right.
I have a question.
Yeah.
So there's the is adjacent method. How many units is considered adjacent?
Oh, did I write it?
I don't know. I didn't. I was confused on that. Because I just used 1.5 as my number. So I think there was a test where it had to be like 1.5 and still turn true or something.
No.
Maybe it was only one.
It should be only one. I mean, the question is, if you're adjacent to the window, yeah, that means that the window is within 1 unit. You can't be on the window, right?
Okay.
I mean, you would break the window if you were on it. So adjacent means you're 1 unit away from it.
I used 0.5 because.
Oh yeah. Good point.
Yeah.
Good point. Because the window is like halfway in between.
Yeah.
Yes, that's very true. All right. The other thing that I want to point out is that when you looked at the slides of chapter 4, chapter 5, right? The chapter on branches. There wasn't much there. There was if and if else and or and not. Those were the kind of the key, the highlights of chapter 5. And that was all. And then when you look at what it actually takes to do this assignment, where you have to put together if and else and or and not and true and false, you see that it gets all of a sudden incredibly complex. The difference between what's on the slides and what you can get out of the book by flipping through the book and saying, oh, that makes perfect sense, and what you actually have to produce in real code and real programs has all of a sudden gotten huge. So we started out with classes because classes are kind of simple. You can write a simple class, you can write those methods, and it's not all that difficult once you get past the machinery. But now we're getting at this thing where students always have problems with not the computer science of it, but with the basic logic. That it has nothing particular to do with Java on how to solve this problem. This problem has just to do with basic, can you think about this thing in a logically coherent way? And students find this enormously complicated. So we're right now in the middle of branches and loops, and with loops it's going to get even more so. And so the only way you can learn this stuff is by doing lots of problems. You can be reading the book until the cows come home, and the book just tells you the basic building blocks. It's like when you read a book on playing the piano, and it's going to tell you about the black keys and the white keys and the pedals. And it says, now go for it. And that's exactly where we're at here. All right, so I can't overemphasize how useful it is to go to CodingBat. I could even show it to you if I had a network connection. And now we're at the beautiful position where just about every problem in CodingBat you can attempt. So here's logic 1. And the one that I looked at this morning is this beautiful problem here called 2 as 1. Says, given 3 integers, a, b, and c, return true if it is possible to add 2 of the integers to get the third. So, for example, when given the input 1, 2, 3, because 1 plus 2 is 3, you would return true. When given the input 3, 1, 2, because 3 is 1 plus 2, you would also return true. But when you're given 3, 2, 2, because 3 plus 2 is 5, 2 plus 2 is 4, and you get the idea. You can't make 1 as the sum of the others, you would have to return false. And so the answer would then be to solve this with a bunch of 1 or more if statements. Or maybe just by saying a single return statement. I can do it just with a single return statement. Okay. I don't want to do it so that I don't spoil the fun. Who is confident that they can do it in 2 minutes?
I could do probably a return one.
Right. Okay, so we have 3 people who are confident that they can do it in 2 minutes. Everyone needs to be confident that you can do this stuff quickly. Okay? Maybe in 3 minutes. I'm okay with 3 minutes. This is like a typical exam problem. But when you first see it, it's very common for students to say, oh, how am I even going to begin to approach this? And so if you're among those, I don't want to spoil the fun. I really want you to think about it. And if you have a question about it, go and put something out on Desire to Learn that says, I've been trying coding BAT 2 as 1. I don't have a clue how to begin. And then I'll be glad to give you a hint. Caught speeding. So whatever. It gives a little programming problem. We can read it. Tea party. Okay. So what the heck is squirrel play? Okay. So these are all pretty easy problems that you want to do. And pretty soon you want to get into the loops problems, which are nicer. Loops. Yeah, where are loops? Yeah, I can't find the darn things now. Somewhere there are loops problems. Maybe they're with strings. Basic string problems, no loops. We don't want those. We want here medium string problems, 1 loop. For example, all right. So anytime that you have a free moment, go to Coding BAT and try one of these things out. I can't overemphasize how useful a practice this site is. Right, now moving on to today's lecture. Just a really quick lecture, since apparently I can't write today. So we're going through basic loops now. Basic loops are simple. You have this while statement that says while a condition, in this case the condition here is true, you keep repeating the loop, and then in the end you go back here, you test the condition again. Eventually the condition will be false, and then you get out of the loop. It's conceptually very simple. The single most important task tool here that you need to deal with these loops is your humble variable table. Let's everyone understand what this loop does. How many variables do we have? We have balance. We have target balance. And we have years. And we have interest is a local variable. I'll put it over here so I don't know. So let's say we started out with a balance of $1,000 and we wanted to get up to $2,000, and the rate is a constant, but we'll put it here anyway. And we'll take as a rate 10%. In the book I think we use 5. That's because 10 sounds unrealistic. Who's going to pay you 10% on your bank account? For that matter, who's going to pay you 5% in this day and age?
National Bank of Java.
The National Bank of Java, yeah. I would kill for getting 5% right now. Let's compute away. So years at the beginning was 0. I didn't put that here. Balance is 1,000. Is it less than target balance? Yes, thank you. So years becomes 1. Okay. What's the interest? A 1,000 times, what's the rate? 10. What's 10 over 100? 0.1. What's 1,000 times 0.1? 100, right? Does that make sense? We get it. It's 10% of 1,000 is 100 bucks. Yeah. So now balance equals balance plus interest. What's balance?
1,100.
11. Right. Okay. We do it again. Is balance less than target balance?
Yes.
Yes. Years is 2. Interest is how much? 110. Thank you. Balance is how much?
1,210.
Yes. Thank you. Is it less than 2,000?
Yes.
And so in this way, you can execute the loop and you can see what happens. So this humble tool is what you want to kind of get a feel for what any old loop does. And you are the computer. You execute one statement at a time. You write on a sheet of paper exactly what's going on. Why is it useful? Because it gives you a feel for, do you need it less than? Do you need it less than equal? Do you need to start at 0? Do you need to start at 1? Because you can simulate these things through. And so I don't even want to say anything more about it. I want to go straight to the lab. Let's look at the lab. So we're going to do lab 8A right now. It's another one of those labs of 4. So if you could do the seating yourself in 4. This particular lab is going to make you do something with the characters in a string. And I've given you the basic outline of the loop right here. Whenever you want to iterate through the characters in a string, then you need to have a loop. So here we have some word. And you start with an index that goes from 0 to 1 less than the length of the text. So this here would be text.length. Here is the last position that you go. Notice the less than sign here, because we don't want to actually go to the text length. You need to extract, because we're going to be looking at letters. There's 2 ways of looking at letters. You can look at them as characters or as strings of length 1. Here, over here, we choose to do it in strings of length 1. This command here extracts the substring from I to I plus 1. That's just a string of length 1, and that's a single letter. I've written you a function here that tests whether a particular letter is a vowel. So we're going to consider A, I, O, U, and Y as a vowel. And we're using the lowercase here so that we don't have to worry about uppercase letters. You can take this function for granted. So what I want you to do is, now, using this basic framework, I want you to come up, but not yet code, I want you to come up with a couple of algorithms. The first algorithm is very simple. I just want you to figure out how can you count how many vowels are in a word. So if you have, say, the word Mississippi, then your method should say 4. Should it? Yeah. But if you have, so that's the easy task. The harder task is I want you to know how many syllables there are. And to compute syllables, the first step that you want to do is you want to look at vowel groups. So I'm giving you as an example to consider this beauty of a word, where you notice it has 2 vowel groups. You're going to count this one as a vowel. Or if you look at this word here, has two vowel groups. This is a group of length 2, this is a group of length 1. And each vowel group gives rise to a syllable, so that's why we want to count them. All right, let's get going.
Are we doing, is it groups of two?
Groups of 4,
Okay.
and we'll do the same thing with the facilitator. Does it say? I don't want to say because last time I messed this up.
Are we going back to,
I think so.